Hi, in this video I wanted to share with you a municipal solar installation that Sunsense installed for Eagle County government, which is located in Eagle, Colorado. This project was an effort to bring this new construction structure to a net zero status and to aid with the numerous apartments, electric bills moving into the future. The project was a new construction project, and thankfully I was involved very early in the design process because this project took on a number of different roof fastening methods that we had to figure out well before the end of construction. The two methods of fastening the solar panels to the roof of this multifamily apartment complex was first a standard flush mount system that we could install posts and then the racking, and these solar panels would be approximately 5 inches off of that roof plane. The second form of fastening was through a mechanically fastened method. And this was because we had a tilted array layout that allowed us to install on a flat roof. And we could fasten to the trusses below the roof membrane, but where our posts did not hit the trusses, we had to install blocking with the general contractor so that we could fasten to that blocking and meet all of the Eagle County building requirements as a result. Here you can see the flat roof mount installation. You see 3 different tables, and they're all at a very moderate tilt at 20 degrees. And there's a number of reasons for that, but the first reason is because the design review board in this jurisdiction did not want the arrays to be visible from the street. And here is an example of the flush roof mount installation where the panels are approximately 5 inches off of the roof plane. And this is considered a standard installation where our crews are going onto the site to the roof and laying out the posts prior to the shingles being laid down. And therefore, the roofer can come back and put the shingles around our posts so that we can minimize any type of potential roof damage. This project was an interesting one from a utility standpoint as well. We worked closely with Holy Cross Energy and negotiated a new form of interconnection for this building. Typically, because there were 20 different apartments, each apartment would have to have their own separate system and their own disconnect, and everything would be running through each individual apartment's meter. In this case, we negotiated with the utility so that we could have one meter ahead of the meter bank, and we could use that power generation and distribute it to each one of the apartments in an equal fashion. This is an example of that house meter, we call it. And this house meter also shows us what kind of service this is. This is a 3-phase project, so we had to keep that in mind when we were selecting all of our electrical components for the project. One of the most important components was deciding on what kind of tilted array for the flat roof installation we were going to choose. And we ran with our good friends Sunmoto and their tilted sun turf system. This is a very lightweight but rather convenient to install type of racking that meets all of the Eagle County standards from a building standpoint and allows us to lay the panels in a landscape fashion so that we can keep that tilt of the array to a minimum. As I mentioned before, we wanted to do that because we don't want to be able to see this array from the street level. And we performed a number of studies prior to presenting our project to the local jurisdiction so that we could show them that indeed from the street level you could not see the arrays, and if you could, it was just a very brief instant and nothing to attract your attention in that direction. The architect and Sunsense worked very closely so that we could figure out whether or not we needed to have a parapet wall put in these areas where the arrays were proposed. In some cases, we ended up putting a breathable parapet wall that helped shade or screen the array from the eye at street level. We worked closely with the engineers from Sunmoto to come up with a proper fastening method for these flat roof arrays. It's very important because we not only want to be able to fasten both to the trusses or the blocking, but we also want the snow to shed in wintertime and not collect quickly and prohibit the solar power generation. So indeed, we lifted the array off of the roof plane 2 feet in order to accomplish this. This is an early diagram of that flat roof array racking. Here you can see that the bottom edge of the solar panels are about 18 inches off of the ground. When we looked at the amount of snow this particular site can potentially gather, we changed that to 2 feet. But you can also see how the array can tilt, which is very convenient, especially in this project, so that we could tilt the array below any type of visible connection with the ground plane. This is the finished product on the flat roof, and as you can see, it's very customized, and we had to work closely with the general contractor well before the finish of the construction of this building because of things like mechanical features, air conditioners, vents, that all needed to be on the roof plane, but we don't want them underneath our arrays. So it was an important back and forth communication so that we could communicate to the contractor where we needed the mechanical elements to be located on this roof so that the array could fit properly and then also operate at maximum capacity. This project with Eagle County, Colorado was a complete success. The building to this day is being used by multiple apartment owners and is benefiting from the solar power generation.